Welcome to the next topic in Unit 1, Optical Fiber. So, optical fiber is nothing but it is used for the communication purpose and will pass a light signal. So, whatever information we are giving as an input signal, that will be received as an output signal. So, basic principle of the optical fiber is total internal reflection. So, to satisfy this total internal reflection, there are some conditions. First condition is light should travel from denser medium to rarer medium, and the angle of incidence should be greater than to the critical angle, and refractive index of course should be greater than that of the cladding. Okay. Now we'll see the acceptance angle, that is maximum angle at which the total internal reflection takes place. How it happens, and the formula we are going to find out from the derivation. So derivation for acceptance angle next in numerical aperture. Let us draw a diagram. Okay. Now we consider an optical fiber. Okay. So inside the center part is core having the refractive index N1, and it's surrounded by the cladding having the refractive index N2. Outside the denser medium is taken as air and the refractive index is N0. Now suppose a ray of light AO passing from the denser medium to the rarer medium at an angle of I. At the point O, it get refracted to the point B at an angle theta. Now here it should satisfy the critical angle. Critical angle means 90 degree. So here this angle of incidence should be greater than to the critical angle only. What will happen? Total internal reflection will take place. Now we'll apply the Snell's law at the point O. So at the point O, angle of incidence equal to angle of refraction. So N0 sin I equal to N1 sin theta, or sin I equal to N1 by N0 sin theta. We know sin theta is nothing but root of 1 minus cos square theta. 1 minus cos square theta. We take it as equation number 1. Similarly, you apply the Snell's law at point B again. So, N1 sin theta equal to N2, sorry, here it won't come the sin theta, here n1 sine 90 minus theta, that is equal to n2 sine 90 degree. Y means this is the angle of incidence at this point. This is 90 degree, this is theta, means obviously this will be what? 90 minus theta. So refractance n2 sine 90. So n1 sine 90 minus theta is nothing but cos theta equal to n2. Sine 90 degree is how much? 1. So cos theta is equal to n2 by n1. Now substitute 2 in 1. So you'll get sin I equal to n1 by n0 root of 1 minus n2 square by n1 square. Okay. So this can be written as sin I equal to n1 by n0 root of cross multiply. So n1 square minus n2 square by n1 square. To take this n1 square outside. So n1 by n0 into 1 by n1 you will be getting root of n1 square minus n2 square. This n1 n1 will get cancelled. So sin I equal to root of n1 square minus n2 square. Since n0 is equal to 1, that is refractive index of air is equal to 1. So I is equal to sine inverse of root of n1 square minus n2 square. So I is said to be the I is said to be the acceptance angle. Next, from this we can find the numerical aperture. Numerical aperture is nothing but sine of acceptance angle. So already sine inverse there, sine inverse sine cancel. So you'll get root of n1 square minus n2 square. So this is said to be the numerical aperture definition.